Hi, everybody. Thanks for sticking around, and welcome to my pod. Again, I'm Nick Tillman. I am the CEO of inRobotics. inRobotics is partnering with Rice University, and my partner at Rice University is Dr. Fatih Gerbel. He's a Rice professor and director of the Robotics and Intelligent Systems Lab. He was supposed to be here today, but he's not. So I'll kind of take you through it. It'll be mostly a business presentation because I really don't know how this thing works. But you're welcome to ask questions for clarity as I go through the presentation. If you really want to criticize something, wait till the end. Anyway, Rice and Dr. Gerbel and his team have developed some very unique and interesting technologies that will enable online inspection of above-ground storage tanks. Now, online means inspecting those tanks while they're in service. There's two aspects to the technology. One is localization and navigation, which is essentially a GPS system that works in storage tanks. Storage tanks, GPS doesn't work in storage tanks. It's a GPS-denied environment. And that's combined with a swimming robot platform that's highly maneuverable. It both swims and crawls. And the collaboration word in there is a bit of reality. In order to really get robotics off the ground in inspection and maintenance, it takes working with end users, and it's a very complex value and supply chain. So it takes a lot of people working together to make this thing work. So why robots? I don't know, you may have heard about the 3 Ds of robotics. You're working on things that are dirty, dull, and dangerous. I don't think any of these jobs are particularly dull. They're definitely dangerous, and they look pretty dirty. But that's not all there is to it. For example, before anybody does any of these jobs, the things they're working on have to be taken out of service. Now, the guy in the upper right is inspecting a storage tank. Before he gets to inspect the storage tank, that storage tank has to be taken out of service, which means it has to be emptied of product and opened up. Once you open it up, depending on what was in it, it releases hazardous vapors, volatile organic compounds, and CO2. Once it's safe to go in there, you have to clean out the sludge and all the stuff that's on the bottom of the tank, and quite often, to do that, you cut a hole the size of a garage door in the tank and go in there with a backhoe and clean out all that stuff, which then has to be disposed of as hazardous waste. And then the tank floor is inspected, and if something needs to be fixed, it's fixed. Oil companies budget about $2 million to take a tank out of service. So that means in a kind of a typically fairly large refinery in the US with about 200 storage tanks every year, they're doing this 20 times. $2 million each, that's $40 million. Now the fee that the employer of the guy who's inspecting the tank gets is probably something around $5,000 to $10,000. The real cost in this is in disruption to the operation, plus the cost of cleaning and repairing. So it really, it really is a strong value proposition that's both safety, reduce the environmental impact, and significantly reduce costs. There's a very large pull for the use of robotics in inspection and maintenance. The Sprint Robotics Collaborative, which we're a member of, was formed back in about 2005 by Statoil, Chevron, and Shell. And since that time, it's grown tremendously. Pretty much all the major oil companies are involved, as well as all the major petrochemical and chemical companies, and everybody else in the supply chain. The main focus, again, is reducing human confined space entry. That's what you hear them talk about all the time. A leader in that area is actually Dow Chemical. Dow has a stated goal to eliminate human confined space entry by 2024. And that's a major undertaking. They have a group that's working on it. They're documenting all their confined space entries. And in some cases, they're requiring senior management approval to put an employee in a confined and dangerous space. And you can see that the goal of Sprint Robotics is to achieve field use of robotics on a large scale for inspection and maintenance in the next 10 years. And believe me, that's pretty optimistic. I mean, we all know about robots. There's millions of them. You know, robots are building cars and computers and working on supply chain. And, you know, there are surgical robots that'll take out your appendix. But as far as inspection and maintenance goes, the use of robots is in its infancy. There are literally less than 1,000 robots available for inspection and maintenance of assets. So we're just getting started with this. That doesn't mean we haven't tried. The two robots you see on the top there have been around since the mid-90s. But they're basically crawling vehicles with ultrasonic transducer on the bottom that inspects the floor of a storage tank to get a thickness reading. If they're lucky, they'll get random readings of maybe a couple of % of the floor, just enough to get an inspector to sign off on an inspection certification, which will allow them to wait another 10 years before they have to open their tank again. I mean, the use has been extremely small and limited to just a few tanks where they actually know that, you know, they're actually aware that the tank probably isn't going to need any repair work, and it's a critical tank that they really don't want to take out of service. The critical thing on tank inspection is to be able to inspect the floor of a tank. You can inspect the walls and the ceiling in most cases from the outside. You have to be able to go in and inspect the floor. And some companies will tell you, you know, they're not happy unless you can inspect 100% of the tank. I've listed a few of the challenges there. There's a long list. There's a lot of things that have to be overcome to really get robots used to inspect storage tanks on a regular basis. One of the things that's very important about this whole inspection business is it's not about the robots, it's about the data. You need to get them quality, reliable, actionable data that allows the people responsible for maintenance to make decisions on maintaining their assets. Now, if you can get that without putting a human being in a dangerous situation, that's good. But it's about the data. And to get people to adopt robotics, we have to do a better job than they're doing today with human beings. In fact, we have to do a lot better job. I used to be director of the energy practice at Houston Technology Center. I've worked with a lot of energy startup companies. You can't make an incremental improvement in something and get it adopted by the energy industry. It's got to be a lot better. And that's really what we're striving for. So here's a swimming robot platform. You know, I'm getting a little tired of calling this a swimming robot. We're trying to think of a name, but you know, all the good fish names are already taken. And so we got to work on something a little bit more creative. The swimming robot platform was designed for 6 degrees of freedom. Mobility, that means it moves up and down, left, right, forwards and backwards, and everything in between. Very precise control. It swims and it crawls. Actually, the robot right below the words there is our 2nd generation robot, and that's it kind of swimming around in a tank. The other one is the one that we recently demonstrated at the NASA Neutral Buoyancy Lab, which was the picture you saw at the beginning. And that one has an attachment on the bottom of it that comes off. So if you remove the attachment, it's a swimming robot with very high maneuverability. With the attachment, it can inspect the floor. I mean, remember what I said, you gotta be able to inspect the floor and as much of it as possible. That little attachment on the bottom from Olympus, that's a phased array ultrasonic transducer to measure the thickness of the floor, which is what you want to do. GPS for tanks, this is actually where the real innovation is. And this is going to have the biggest impact on the industry because it removes the major barriers to expanded offline and online robotic inspection. Actually, that sentence is incorrect. It does remove the barriers, but you really don't want to expand offline robotic inspection. We want to reduce offline robotic inspection. But the way the navigation system works, it will have an immediate impact on the offline inspection. The way that navigation has been used for some of the other robots that are out there is, they'll position maybe 3 or 4 transmitters on the outside of a tank, and then somehow the robot will pick up the signals and triangulate and more or less try to figure out what its position is. It's a very iffy thing. If you've got a smart engineer doing it, it can probably be fairly accurate, but if not, sometimes it shows the robot outside of the tank. The system that Dr. Gerbel and his team have developed have a pretty easy setup. It's on board. It'll be located either on the scanner you see over here or on our robot or somebody else's robot. And it will be accurate through within millimeters. And because of that, you'll be able to assign data to a specific location. You haven't been able to do that yet in inspection of storage tanks, even out-of-service inspection. So what that does is enables the asset owners to take that data and do some statistical analysis. Even stuff you've been hearing about around here, digital twins, AI. So instead of opening up a tank every 10 years and doing all the damage that it does to both the bottom line, the environment, and the human being that's got to go inside it, you could use risk-based analyses and maybe extend that period to 15 years or more. So you actually want to reduce online inspection even while you're doing online inspection because you're going to get better data. So how does it work? That's kind of our lab setup. Under that red triangle is a proximity sensor that bounces signals off the wall, and it uses the geometry of the tank to actually map the tank, to do a map in a grid. And it also uses, in doing so, it finds the center of the tank, and then there's a landmark in the tank. In this case, it's that kind of round thing over there. And it draws an XY grid and shows the position of the robot as it moves around. We call that map-based positioning. Some of you may be familiar with the term SLAM. Simultaneous localization and mapping. It's how driverless cars work. And that's kind of what we're doing with the robot. It's using the geometry of the tank. The Rice people have been studying the geometry of circles going back to Pythagoras, and they've got some very sophisticated algorithms that don't even need all the data on the circumference. They can take a small portion of that and start drawing the map. And you can see, here that the position error, again, is within millimeters. So we took that actually into an empty tank with one of our partner companies, HMT. HMT is a major tank technology company and also an inspection company. And I'd like to tell you we took it in there and it worked immediately, but it didn't, because tanks aren't really round, they only look round. And the floors of tanks are kind of uneven. Tank floors are made up of plates. You'd probably fit 2 plates into this room. Some large tanks might have 100 plates. And so what they do when they do a traditional inspection of a tank is they actually map it plate by plate. And what they do with a scanner is if they see something that looks like there's a problem, they have a very important tool that they use, and that's either a can of spray paint or a piece of chalk, and they mark the location. And then they come back to it with maybe a UT sensor and decide whether to fix it or not. And usually the way they fix it is just weld another plate. Anyway, that's where we are with that. Working with HMT, we managed to robustify the algorithm so that we've actually repeated the lab results, and we're able to get accuracy to within millimeters. The next step with this is to work with HMT, and we're also working with one of the scanner companies to look at integrating that localization system with their scanner. So we're looking forward to that. And we think that by sometime in 2020, we'll have our first commercial product, which will be that technology. So we're really looking forward to it. So I mentioned Sprint Robotics. And one of the things that the Sprint people do, and having Sprint Robotics involved in this is really great. Because first of all, you have all the players in the same place. And they've done what they call an innovation landscape map for ASTs. And we've kind of shown how the things that we're working on really advance that, the various projects and the use of robotics in above ground storage tanks. So I don't know if you guys, some of you are probably familiar with technology readiness levels from 0, which is I'm just thinking about it, to 9, I got something that works. And they've also added a business readiness level, which means is the business ready to use it? And again, particularly the localization system, that will add to the ability of the robots that are already out there and even the things that are done remotely or manually to be much more effective. And it will enable autonomy. So it'll help get to the point where we can take our swimming robot, put it in a tank and leave it there, maybe forever, while it continuously inspects the tank and let it do the job by itself. Of course, there's competition. If nobody else was working on this, then it probably wouldn't be a good thing to be working on. So we know that some of these companies, and I've kind of put them in 2 categories. There are robotic inspection technology companies that are already working in pipelines and sort of other applications. GE Inspection Robotics is one. Anuktun has a crawling robot that can inspect the outside of tanks. Diacont actually does have a crawling robot that kind of builds on the technology that's already been developed and has a little bit more sophisticated localization. Cellular has this cool little thing over here, which is kind of where we would be going. I mean, I don't think they've gotten past the design stage, and it's no longer on their website, and they don't return my phone calls, so I'm assuming they've given up on it. And then there are the ROV companies. Oceaneering's the big one that people are probably familiar with, and there's some other big names there. I know some of them are working on this. Some of them we're in contact with, and really, I don't mind competition because it's an opportunity for collaboration, and it's really going to need people working together on it. So, okay, so I'll just leave you with a video, see if it works. Okay. Maybe it doesn't. Is this on a... That's okay. I can tell you what happens. Yeah, in fact, this was, you saw the picture at the beginning. I'll show it to you again in the end while we're taking questions. It was done at the NASA Neutral Buoyancy Lab. So we did a project with them, or rather Rice did, on subsea robotics. And that's how we got to use this, world's biggest swimming pool. And it's really a fabulous facility if you've ever been there. It's kind of fascinating. What you would see here, that's the robot in the bottom right here. Can I go outside the box? And what you would see is the robot coming down and landing on the platform. And the way it moves, well, first of all, it's neutrally buoyant, so it can move around and swim. But with the attachment has a ballast system. So it can actually take the liquid that's in the tank to give it some ballast, move down to the bottom of the tank, and then it deballasts, and when it deballasts, you can see it rising up a little bit off the bottom, becoming neutrally buoyant again. And then the thrusters, it has a really unique thruster system, moves, and the robot moves back up again. One of the things you'll notice about the thruster system is there's no turbulence. Right? It's not kind of moving back and forth, or you don't see a wake. And that's done on purpose because first of all, you need to be able to have very precise movements because these things are going to be operating inside a storage tank with obstacles you don't know are there, so it's got to be highly maneuverable. And the turbulence would interfere with some of the sensor systems that we might be using. So that's kind of important. Okay. So there's another robot. When the robot has already landed, robot picture. This actually shows how it will scan the bottom of a tank. There's a hand that comes in and it puts a little piece of metal or something there, which was actually brought by Olympus, who's our sensor partner. So they've got something that's calibrated and they know the thickness, and it shows the robot maneuvering over that kind of piece of steel and getting a very accurate reading. So we've demonstrated with a swimming robot the maneuverability. We've demonstrated that it can do a floor inspection accurately. So the next step with that is to actually build one that's robust and then get it certified. That's a multi-year, multi-million-dollar project. So what we're really focused on now is the localization system.